Assalamu alaikum wa rahmatullahi wa barakatuh. So, after getting the first step done of the self-balancing robot project, which was obviously to make it balance, now the second step comes into play. And the goal now is to give the robot some legs to be able to change its height and do some other stuff as well that I don't know yet. But that proved to be quite challenging, actually. Anyways, so first thing I did was trying to find what mechanism I should use for the legs. And after doing some research, I ended up choosing the parallel kinematic mechanism, which consists of 3 links, and it only needs 1 motor to make it work, to move the leg up and down. After I found the correct mechanism that I can use, I went onto Onshape to start designing the robot and see how it would look like. And after that, I printed the first test case. And now, so far, I printed and tested not only 1 design, not 2, not 3, but 4 test designs. And all of them failed. For one reason, which is I don't have a powerful motor with enough torque to lift the body of the robot. So I'm going to show you, the timeline, or we can say, of the tests that I made and how I moved from one test to the other. So this was the first design that I printed. I had some designs beforehand, multiple ones, but I kept changing them, to make it more efficient for 3D printing. And this is the simplest design, just to test out the theory. I only had like a small box and some cutouts for the servo motors to attach them to the body. And here would be the place for the DC motor, for the wheels. So the whole idea was these here will attach to the servo motor through the horn that it has. And basically the robot would be able to, move up and down like this. Like you see, the leg would be here, then just go down and up. But this wasn't successful because the servo proved to be quite weak and couldn't even hold this. This is like 150 grams, and it wasn't able to hold it. Like, it can hold it, but with my hand helping the robot, stand. So the problem with the first design was that the servos proved to be quite weak. They couldn't lift the body of the robot, which was only around 150 grams. I don't know why the servos are rated as to have like 10 kilograms per centimeter. I'm using the MG995 servos, but to be honest, it's also part of my mistake because I didn't do the math yet. I should do the math first, but I didn't. I just jumped onto designing and testing. So to get around this problem, I thought maybe I can use gears, to amplify the torque of the servo. So I used a 1:2 ratio, and I tried to print this next design. But before that, I also tried to do some changes to the body of the servo because I thought the square was bad, was too basic. And I came up with this. This was the second design for the body of the robot. But this was not optimal at all because I went for looks rather than efficiency while designing this part. And you can see I made this whole extruded thing from the back of the body, which affected the center of mass so drastically. And like the center of mass is like around here, or here. Yeah. And the leg would be here. So the balancing mass should be around here. But the body of the robot has a bad center of mass, and it's around 250 grams. So I said, all right, I'm gonna try to design another one. So after a long time of designing and trying to get the center of mass correctly on the body of the servo, I came up with this design. You can see, to be honest, this is the best design that I made. It looks nice. It looks really cool. You can see it, and you can see the servos inside here, and here are the gears. You know, I have around 15 gears, 15 teeth, sorry, here, and 30 teeth here. So that's a 1:2 ratio. Basically what happened is that it failed as well. The servos got a bit more powerful, but not quite enough. You know, I don't know why. I didn't do the math yet when I designed this. Mistake, yeah, I know. But I just tried to think about another solution. I want to use the servos because, you know, they're easy to control and they are quite precise. However, if I want to use the servo still, I'm gonna have to buy a more expensive one. And I thought, before I do that, let me try and design something new. And this is what I came up with, using DC motors, because I thought maybe it will be stronger. It's a 280 RPM. It's what I had before laying around, so I said maybe I'll use it and just see how it works. And this is a simplified design just to test things out, because I wasted around 1 kilogram of filament on these tests. And like you can see how the mechanism would work. Like you see, goes up and down like this in a straight line. It's not really straight, but it's as close as I could get it to be. But of course, it was too weak still. So, I am left with disappointment, and I feel like what I have to do is just buy a more powerful motor. I'm gonna buy the servo motor, 20 kilogram centimeter servo motor. However, I'm gonna do the math. I am, because that's a lot of money, and I need to know for sure that's what I need and it's enough. But maybe before I buy a more powerful, expensive motor, I thought, what if I use a planetary gearbox? Maybe. I thought I might use a 1:5 ratio now, because the planetary gears are, you know, quite compact. I'm gonna try them and design them and, you know, print them and test them. And I really hope that works, because that's gonna save me a lot of money. I'm, you know, planning to use the gearbox with the servo motor that I have currently. Well, that's it, and see you hopefully when it's all done and working.